Okay, POE, we're going to try to do the 3.1.1 Vex inputs and outputs, and I have Robot C loaded up right here, and I'm going to attempt to try to do this with the test bed going, so you'll have some pictures down the bottom that'll show you the test bed running as well and how it actually works. I've got a green light, which means I've got a good connection set up on it, and let's see if we can actually get some stuff going. I'm going to try to open my test bed file, so I'm going to go look and see that I can find it. There's test bed template, so I'm going to open it up, and just I'm going to double check and make sure that all of these sensors actually are where they're supposed to be. Line follower, potentiometer, light sensor, looks all good. So I'm going to go ahead and try to get this thing up and running. So the first thing that I want to do is I want to hit compile, and I don't have really any programming inside. It's just a blank function, but that's okay. We're going to mess around with a debugger for the moment, and then I'm going to hit download to robot. And there is a good chance that whenever I do this, my computer is a potato and it might actually freeze up. If it does, I'll just restart it and we'll just keep on going with it. All right, so I'm looking down here, and uh, this window down here is called the debugger window. And if you don't see this, if you just hit it and then you just see this little window that comes up over here, what you need to do is you need to go to Robot, and then you need to go to Debugger Windows and make sure that motors and sensors are checked here. There's a whole lot of different things that you can use to debug this system. So we're going to make sure that we do the motors and the sensors for this. And you should see down in the bottom that we have the flashlight, the right motor, the left motor, and the servo motor in the motors with the PID. And then for the sensors, we have line followers, light sensors, bump switch. Looks like we've got everything that we need. So I'm going to go ahead and I'm going to start messing around with this stuff. Make sure that your debug window has continuous inside it for the refreshing. That way, whenever we put things down here, it should actually show up in the test bed over here. Okay, so first thing that we're going to do is, let's see, we're going to go to the power column and we're going to test out the power on the VEX 393 motors. So if I click on this window that says power and I change the number, it says, enter several values from negative 127 to 127. I'm going to type in 20. Whenever I type in 20, it looks like I have a motor that starts actually going. If I type in 40, then that number goes, you can see that the rotation increases. If I go to 127, this is max power. This is as fast as you're going to get this thing to go without gears. And then if I go back to 0, it stops. And then if I go to negative 127, it goes the other direction. So I'm going to go back to 0. All right, that one's fair. So it looks like 127 to negative 127 are the values that go for these motors. Make sure you record those observations. And now we're going to check out the sensors that go along with this too. So next thing that we're going to check is we're going to check the line follower. So I'm going to go over to where it says sensors down here in this bottom tab. And you can tell that there's values that go along with these sensors. And the line follower is this one right here. And if I put my finger over the line follower, I can see that the value, which is right here, changes. So finger off, okay, finger on. So whenever you put something on there, this value is going to drop. So as something is really close to this line follower with a color change, and I can try this with like different colors too. So if I take a different color and put it under there, see how whenever I made this like a white background, that the white background becomes a much lower value than if I were to take like my finger, which would give you a value of about 400 or 500. If I take a dark background, such as like this rubber stopper, then notice that that line follower value is like in the 2500s. So you can definitely tell a difference between this at 2500 and this color at negative 100. So it's actually pretty easy to see the difference between those. Next thing that we want to, oh, make sure you put that in your engineering notebook. The next thing that we want to observe is the potentiometer. Now, the potentiometer looks like this. We've just got a drive shaft on the end of it. Put that back in there. Now, some of these potentiometers, you got to be careful with them because, there we go. they have a range on them. So if you go outside of that range and look like the highest number, I'm getting resistance right there. The highest number is 4,095. If I twist this the other direction, the low number looks like it goes to, there's our resistance. It goes to 0. So I'm getting a resistance there, and that potentiometer goes from 0 to 4,095. Those numbers are really important. The light sensor on the next one. Oh, let's see here. Let me actually go in the order of the thing. So I'll get back to the light sensor. The limit switch, which is this one right here. It's got the little clicky on it. Okay, I'm going to go try to find it if I can see it down here. The limit switch down here says that it's touch, and whenever I click on it, it should go from 0 to 1. But it looks like my limit switch isn't working. So I'm going to check the connection to make sure that that's in the right spot. It looks like it is, so I'm just going to blame this part on my kids and just say that, oh, well, okay. Whenever you click on this, this should go to a value of 1. Same thing for the bump switch too. Oh, they've got the bump switch in the limit switch spot. Oh, congratulations, guys. That's not good. That's not good. So whenever I click the bump switch, you can see how the value changes from 0 to 1. Okay, the same thing should be happening with the limit switch too. So whenever it is pressed, it is a 1, and whenever it is not pressed, it is a 0. At least I can get some functionality out of this video from it. We'll have to have a talk with them later about that. Let's see here. The Quadrature Encoder will actually measure rotations. Right now it just says that it's at a value of 1. This little red box is the Quadrature Encoder. So as I move it around, we should get different values that go along with it. Looks like my values are only really going between like 1 and 2. These should be a lot larger number of a value. It should be giving us much more than that. So I'm going to have to check this one as well too. They might, because there's 2 different wires here, they might actually have these plugged in backwards instead. So if your Quadrature encoder in Robot C doesn't give you the right values that you want, you may need to go back in here and check that these wires are actually put in the right spot. If they're not going to give you the right values, and you're going to have to switch them over. Okay, the sonar looks like they've got the same problem. If you get a value of -1, then that means that your wires aren't configured in correctly. That means they've got them in backwards. Let's see if I can try to fix this. I may have to recompile it to get it to work, but I also don't want to make this like a 15-minute long video. So let's see here. We're going to identify this is one of the wires, and this is the other one of the wires. And they have them. Let's check and see if I can actually get this in the right spot. They do have them in the roughly correct spots, but I'm going to just take them and swap them real quick. I'm going to see if that actually makes a difference. Oh, no, they've got it actually pinned down here, so I'm actually not going to waste time on that. You should see numbers change on the sonar sensor. As you move away from it, that number should get larger, and as you get closer to it, that number should shrink down. So if you've got it wired correctly, that's going to be what you're going to see there. The LED, hopefully, is the last one. I'm going to change the value of the LED. I'm going to go down here and see that I can, let's see here. Okay, so we're going to, on the LED, right now it's got a value, oh, let's see, there it crashed on me. Just kidding. Gonna have to go back into it. To get to our last ones, the LED should light up on here if you change the values from 0 to 1. So I apologize for the potato doing its crashy thingy. I'm gonna go back in here and open the testbed template, compile, download. We should see our stuff come back up here. All right, there we go. I'm going to just try to change these real quick before it crashes again. So I'm going to try to change the value of the LED, and I'm going to change it to 1. Okay, when I change the value of the LED to 1, the LED lights up. When I change the value of the LED to 0, it does not light up. So you've got on and off. So LED 1, LED 0. Okay, and I think there's 2 more things that I need to test out. I need to test out the flashlight, which is right here. Hopefully you guys will be able to see it. And I'm going to go back to the motors, because remember the flashlight is actually in the motor. If I change the power value to 20, I can see that that turns on. If I go to 40, It looks like it glows brighter. 60, 80, 100, and it looks like the power says that it's negative 100 on the robot C. So maybe if we change this to negative 40, oh, negative numbers don't work on the power part, but that's because it makes the power negative. I must have this reversed. So I'm going to go to positive 50. So if the LED flashlight does not work, try a negative number and see if it'll actually work as well. For me, it works with positive, but if people flip it in the motor and sensor setup, then you might have to input a negative number as well. I'm going to go to a 127. That should be as bright as it gets. So if I go to 500, it's going to be like, no. Yeah, see, it doesn't really get any brighter for 500, and it just goes back to 127. This is the highest number value that you can get. Back to 0. All right, the servo. Let's try this. I'm going to move the 3-wire servo to position 20. And it looks like they don't have the servo working either. So the way that the servo works is the servo will, if we can actually get it to function, will move to a position. So if I type in a value over on this side, it will move in a location. And I can tell that they've actually got it plugged in because if I try to move the servo, it actually fights me. It's not like the motor, because the motor I can just easily turn like this, but a servo only goes in certain positions. So if I type in the position in Robot C, this should actually move to that particular position. I'll have to check and make sure that they've actually got this one wired correctly because it doesn't seem to be working. But it looks like for the test bed, looks like my students have it about, 50% on it. I think that I think let me check the light sensor for one more thing. Yeah, the light sensor is right here. And it kind of works the opposite of the line tracker. If you get a shade or a shadow, it gives you a large value. If you have light, it gives you a small value. So in the open light of the room, this gives you a value of about 90 to 100. If I put my finger over it, that gives it about 700. So for a light sensor, it's the shadows give the higher numbers and the open light gives the lower numbers. That's important for this one. Okay, I think we've covered about everything that is here. I wished everything worked, but maybe I can make some videos where these things actually function later. But you guys have a great day. I think you get the general idea of it, and I will talk at you guys later. Have a great day.